Well, the Greeks held that the visual arts were the imitation of life, but the computer arts are the imitation of creation itself. Thank you very much.
When I left Glenn's group, I spent a very short time working for Litton Industries on a precursor to the Skylab. And then I went on to a conference that was being held up in San Francisco. This was the Fall Joint Computer Conference. And this particular conference was very, very special for me, and I think for a lot of people, because there was an hour-and-a-half session here where Douglas Engelbart and the Augmentation Research Center in Menlo Park, California, was demonstrating a live video demonstration of the highly interactive computer graphics and computer text manipulation system that had been developed at SRI. And I went to that particular session, not knowing what to expect, and I was completely blown away. And I happened to find afterwards the particular person who seemed to be in charge technically. His name was Bill English. And I cornered him and I said, this is really nifty and I think I can help you. And I was fairly bold in those days. And he said, well, actually we are looking for a few good people. Why don't you come by? And I think the next week I went by and the personnel department said, no, we have no openings. And I said, wrong. I'm going to sit here until Bill English comes and talks to me. And I did. And he did talk to me, and they did hire me. And it was the beginning of a 7-year effort on my part at SRI with Doug Engelbart. And it was a very remarkable experience. And a great many of the concepts that people now think of as commonplace, like multiple windows and the mouse and editing across windows and integrated text and graphics and all those kinds of things, all originated from my point of view in the work that Doug and his group did at SRI. And so I'd like to introduce you to Doug Engelbart and his perspective of the last 20 years or so.
All the equipment. So I usually proceed to botch up the use of these things just to prove that you can be an expert in man-computer or hardware computer systems and still be human, right? Before I start my own story, I'd like to make a commercial pitch that I promise the people who are busy at Stanford University developing historical archives, especially of the technology things that are burgeoning around this area, and all this stuff is pretty good. So they've got a program for collecting and archiving all the kind of records and data in a place to keep it safe and available to scholars who want to dig in and really find out the truth about who's lying when they say, you know, I developed this or that. And so the records from our lab are due to go into there, and it's been very interesting to me to learn more about their story. So Henry Lowood over here, raise your hand, Henry, is the advocate turning these out. So if you want to kind of connect with him and give him a chance to pump you and tell you about his program, I'd appreciate it if you do it. I think it's a great thing to do. All right. Now I'm supposed to sell my own product. In the paper that I wrote, I emphasized the fact that most of my things sprung from a particular quest I've been after and the framework that I developed to think about it. So I'm going to focus on that quite a bit, and some of it is conceptual and not technical. So just to put that, though, to give you some reality, if possible, to hang that on to, I'm going to dive into some of the technology early and then go to the concepts and then go to a little bit more technology. And I try to put the concepts where if I don't finish all the slides, I still get to it. because that's one of my real failings is I start talking and I get gabby about sharing what it felt like, and I don't get through the whole program. So let's start with the first slide, please. When I was in just about this time, 35 years ago, I got this big kick that I'm going to do something meaningful and contribute to society. And I went through a whole bunch of analysis that I outlined a little bit in that paper and came up with a big flash about, hey, you know, the world really is in a pickle. Our complexity of our problems is growing and growing very fast. And the urgency with which we have to deal with them is also increasing, and that the product of urgency and complexity essentially is a measure of the difficulty for humans in coping with problems. So what happens when that difficulty surpasses our capability? That we get farther and farther behind in coping with them. So I looked around and I realized, well, in 1950 or 51, we already were too far behind. So if there was something that a young man could do to help humanity cope better with complexity and urgency, that'd be a nice contribution. So all right, I commit. And I just got married, and my lucky young bride got to move to Berkeley with me and struggle through graduate school and learn about computers, and then find out that what I wanted to do seemed to be just unthinkable in any kind of academic or research world. So with a great deal of struggle, I just did some component work for a PhD thesis, and then hunted around and decided that SRI, Stanford Research Institute, would be a place that if I could sell the idea to anybody in the world, they could put the money into there and I could assumably do it. So I went there, and it was after a couple of years of, well, I was lucky, and I worked with components and got a bunch of patents and built up some sort of reputation. So, all right, we'll give you a chance to do what you want. But about 3 or 4 weeks into doing what I wanted, they changed their mind because it sounded so strange and weird. But so it was quite a struggle for the next few years. And I finally got a little bit of support from an Air Force Office of Scientific Research that grub-staked me partially for a few years. And I developed what's called my conceptual framework for doing what I wanted to do. Okay, that launched it. Oops, wrong button. I'm just showing you I'm human. So, all right, from 51 through 57, I was at school and preparing and searching and finding out that the world didn't quite think like I did. I got a chance to build a framework in there, very awesome work, just me. Very lucky when Licklider came to our office that I was there waving and saying, I want to do this stuff, and it sounded something like what he wanted to do, so what could he do to be, he's a very fair-minded guy, so he had to give me money. So that started, and we built the laboratory, and by 69, there was a system that had quite a bit of the functionality that I was thinking about with the framework, and there's a lot of strategic thoughts in that framework that I'll get to later. And so we'll show a movie that was really made in 1968 at a presentation to give you an idea of what we'd done by then. And then more later, touring, getting involved in network, and started to sell service to people over the network in 74 to just get real users, very important part of the concepts in here. And then everything crashed, and we got converted to commercial world, and a lot of struggling since then with a lot of education about that other world out there. And a year ago, the company that SRI sold us to, Timeshare, got bought and turned by McDonnell Douglas, and they're inside a heavy industry world with lots of CAD, computer-aided design, big project work. The kinds of things that we've been wanting to do just fit beautifully. So momentum is going to pick up again, and I'll get to that a little bit maybe. So this is just an outline of the kind of support that we got through those years. And I just must say that the kind of luck to stumble on and get the kind of support we did and get the research money and get to belong to that community, it was just absolutely, you know, couldn't have done anything without that. So here's the document that I produced in 1962, and that was condensed into a chapter in a book in 1963. And a lot of the framework in here, it's verbal, couched in terms that today aren't very meaningful to any people generally, There's been almost no dialogue with people about what's in there, and yet to me it still says what has to be done. It outlines a basic sort of strategy that is matured to some extent, but is extremely useful and I think very valuable, and I'll try to get to some of that today. This was about 1964, I guess. This was our second machine and so on. This was a standalone workstation connected to a CDC 3100 that we had to go custom build this thing and the electronics to drive it because we unfortunately weren't tied to a whirlwind or something like that. So that was about 10 to 15 times as expensive as what you'd have to put into, say, an XT today, something just to make that. And then we wanted early to start experimenting with the screen selection thing. The idea of working and interacting very, very actively with the display meant that you had to tell the computer what you were looking at, so you needed a screen selection device. So there was a lot of argument about light pens and tracking balls in those days. So what I wanted to say, though, in the context in which we wanted to work with text and structured things and interacting with commands, I wanted to just find the best thing that would work. So the context was important, and set up experiments to do that. And among all the things, we just built a mouse. So it was our very first mouse, see? And somebody at a conference last spring hung it up like that and then looked and says, "Oh, it's a girl." And I'd never noticed. Anyway, so no one's quite sure why it got named a mouse. You know, it looked like it and all of that, and none of us would have believed that the name would have stayed with it on out into the world. But the thing none of us would have believed either is how long it took. So anyway, the experiments that were done to sort of verify that a mouse did work better in our environment. And we also experimented with a way to jiggle your knee up and down and wiggle it sideways to move the cursor so you could keep your hands on the keyboard. And I built something that you could move your head sideways and the cursor would go and your head up and down. So you could just be going like this with your hands on the keyboard. And in each case, some muscles would cramp up. But these are just experimental data to verify to people see. But really, in almost any of these cases, you can get used to things like that. And I'm sure there are a lot of things to explore in the future about what best is going to work for interfacing so that you can tell the computer what objects on the screen you want to direct its attention to. But we have many things to do, so it's kind of like diminishing returns for us to pursue on that. So. And another display system we built by the time we got a time-sharing system. First one we got was an SDS 940. And so this is the hardware here was a lot of little small CRTs, 5-inch CRTs that happened to be the most economical size for a given percentage of resolution on. And then commercial high-quality video cameras mounted with a shroud over them, normally looking at it. And so as that video signal amplified and piped out to the laboratories that provided us our display systems, and quite a racks of them like that, and it took 1.5 people sort of to keep those things running all the time. So the cost in those days of getting display systems to work with was really quite high. And there was a strategic plan, according to that framework for me, that to skip typewriters and go to displays, feeling like there's a great deal to learn about how you can harness that technology, and by the time we really learned how, the prices would be down considerably. So this was our workstations out there with a TV monitor and a little wooden table we made, and a keyboard and a mouse and a key set here. And so Licklider and I disagree on quite a few things. My framework is just different, see. I look there and say, well, we really want a detached keyboard, and we really want to fix it so what you're going to look at is positioned so it's best place to see it, and the controls you're going to do to control what the computer does to that, where it's best to have those located. And don't get caught in an anachronism of saying, because we got used to paper and pencil and that technology, that we ought to be able to have our controls right on the surface of the thing we're working on. So it may end up that way best, but don't make an a priori assumption. So we didn't, and we worked this way. And let me tell you a little bit about this too. That's a terribly, terribly difficult thing to use, see. So one of the things that you say, if you want to explain to somebody why it would make a difference if you can do things faster, And I struggled in those days. Much of that struggle was mentally about 4:30 in the morning, because I must be crazy to be going through all this. You know, everyone thinks I'm nuts. Maybe I am. So I thought one morning, hey, I keep trying to tell them it'll make a change to go faster. Just speed will. Well, and they can't quite see why. Well, what if I show them and actually have them write like that? Because it's only a matter of happenstance that the scale of our body and our tools and such lets us write as fast as we can. What if it was that slow and tedious to do it? And a person doesn't have to work that way very long before you'd start to realize that our academic work, our books, a great deal would change in our world if that's how hard it had been to write. All right, so what if you speed it up? So all right, the key set is just one way, and it's an option, and it hits characters. When you hit chords like that, it hits characters, and that's the code. And it really is very difficult. Like my 6-year-old kids learned it in about a week, and other people, we had some subject one time to try a teaching system, and we used this for the very first thing to learn. And the experiment blew because everybody controlled and everybody else learned it so fast you couldn't differentiate between those who did and those who had, those who had special computer aids and those who didn't. So here's sort of the picture that I kind of think about this. You got to make it easy to learn. See, all right, how much is it worth to you if you're going to get around a lot in the world and something's going to be just a thing you live with, and that's your mobility thing? So what is a few hours of learning how to ride something as unnatural as that, as contrasted to I can immediately pick it up and work with it? See, all right, so all the way through you got to think about it. And when we get to the framework, I'll just tell you some more about the things that we have to do to sort of open our minds to the changes in the human side of things to harness the technology. Okay, so by 68 there, I had a workstation like that in my office and just started living on it. And out in our lab, we had 6 to 10 more, and time shared among people. And the whole feeling was great, and it was very, very interesting sort of activity in those days. And who says we didn't do workstation research? So this one got to be one of the favorites for some reason. People sat there. Notice the traditional way that our system was called NLS then, and now it's called Augment. But this is what you see all the time, people sitting there working and occasionally switch to type on a keyboard. And the speed and flexibility of that you'll see in the movie a little bit, and it's quite unique. So I just had to find an old picture of Charles Irby in here to prove, yes, he was there, and he did look younger, and yes, he went through the 60s also. He looks so clean-cut now, I don't recognize him hardly. So here's Bill English. This is a workstation that we had made for us out of the courtesy of Herman Miller, who was trying to experiment with us. So this little console swiveled on one of their Eames chairs, and it went where you went, and you could lean back and work with it very nicely, and was separated from that. And I looked for this one particularly. I wanted to show this workstation, but also for Bill English, who just deserves an immense amount of the credit for getting things to work. He just made things work, and I wave my hands and point and somehow don't make much progress, but he really helped make things work in those days. So I owe him a lot. All right, the presentation we gave, here we'd been working, we had this marvelous system. We try to tell people, a few people had come and visit us, but I thought, gee, it's time that we showed people. So we took an immense risk and volunteered for the Fall Joint Computer Conference. That'd be like the National Computer Conference today in San Francisco in December '68, which would be, what, 17 years ago? All right. You did the arithmetic. And so we set up to give a presentation here with a video projector pointing at a screen, and it's a great big auditorium with a balcony, and that video projector could put the text we piped up to it on there so you could read it from up on the balcony. And down there in the corner of that place like that, this is the video projector we rented, and it was an earlier version built by a Swiss company of the kind of thing that's back there, but the same kind of technology where it's actually a high-intensity projection lamp whose light is modulated by a thin film that's in turn, et cetera, et cetera. But anyway, it's very, very effective. So we had a 20-foot image on the screen. Up in the upper right hand on the stage like that, we put a backing like that, and this Herman Miller console situation. I sat there, and we built special electronics that picked up the mouse and keyboard and stuff and piped it down there because we didn't have, it just wasn't any way to do it otherwise in those days. And we leased 2 microwave lines up from our laboratory in SRI up here in Menlo Park, so it was roughly 30 miles, and it took 2 dish antennas on the roof there, 4 of them on a truck up on Skyline, and 2 on the roof of the conference center with cables like this, and it cost money. And running that video projector and getting people to help us do all that cost money, and making the special I/O things cost money. And running this thing like that with leveraging technology on technology was highly risky. So when you see the movie and see me start sitting up there, you realize I was risking a huge amount, and I was using research money that the nice people in ARPA and NASA who were spending us like that had to say, don't tell me. Because, you know, if this had flopped and we would have sort of got in trouble. But anyway, it worked, and the main reason it worked is because Bill English is a genius. All right, so back in our lab, we dismantled a lot of the cameras that we'd been using in our display system and borrowed these things and got people to be camera people. And one of our friends was named Stuart Brand, who was at the time working on his Whole Earth catalog, and he came over to help be a camera person and such as that. So it was really a real group project. There were about 17 of us in that time, and we ran it. So I sat there, and on the console there was a camera mounted that catches me in the face. Up there's another camera mounted that can see the keyboard. In the back of the room, Bill English sits with the 2 video signals coming up from SRI that could either bring camera or computer video, and down there they would switch on. And he had an intercom. He'd tell people, bring up this, bring up that. And he also had these 2 camera images, and he could connect any one of them and do this frame splitting and mixing. And so I worked up this scenario, and I sat there and started flying it. And I've got a headset, and you know, when I talk here, it comes out on the PA system, but they can all hear me in the background, but I can hear all of them in my ear. And so I'm running this thing and flying it and going according to that, and every once in a while a look of just, you know, and every once in a while I stumble badly because it's a little disconcerting, and someone's just, oh, it doesn't work, we'll never make it, you know, and switch around like that. So you have to think about that when you watch this movie. And another thing is that, and it was hard enough to remember what I was going to do and then to say, because I couldn't have a script to read, and thought of that. But another thing is that the system we used, we didn't use anything special. We're just using NLS as the way it worked at that time, and yet it had mixed text and graphics, so we could use those to display and represent things. So part of it was we'd have the agenda there, and we could run different things and diagrams, and part of it we could do things as examples. So it was a mix of things of here's the script and stuff to tell you about, and then here's the way it runs. And we could also bring other people in and out on the thing like that, and it would be as if we could have run it today here, something like that. And at that time we firmly imagined that by this time that's the way conferences would be run. So that's the way my face would appear. I'm the guy on the right, in case those few years matter like that. So, and then we could do this kind of splitting, where this is the camera here, camera coming up from SRI, and that happens to be the agenda list, and a little marker there to say I'm between those 2 items right now. And I make a temporary list here. We did start structured idea processors, what you have like that. I was just doing through a list of stuff my wife wanted me to bring from the shopping, and getting it structured and organized flexibly, etc. And then we wanted to show how the mouse works. So this is a picture of Don Andrews' hand down from our laboratory, moving the mouse around, and the cursor would follow it exactly like that to show how that, and he'd turn it over and show how the wheels work. And then when I was running it too, I could do this by showing how the 2 work in combination, and there's the screen on which the things are happening. Then we brought up Jeff Rulison, who was going to tell us about software work, and at the same time his face could come in and out behind the things he's using, the source code and the moving around, and showing how he could work on that. Very, very, very explicitly structured software, etc., which was the first. And He showed graphical diagrams which are through there like that. And he could also bring up in the background, while he's working and talking and diving around here, you just see his hands working on this thing with no great sweat. Well, I had to go through this hour-and-a-half thing and just pull out like 15 minutes. So it's got several seconds in between gaps like that. And we're just going to run it. And I'll apologize later. Towards the end, what we did was also show that we could cut a hole out there and see Bill Paxton's face from down there, and then go back and forth with his screen and such, and we could trade who was controlling all of this. And I think I'm going to have to just let him come on and see that that works, and then cut him off at the end of this thing. So, all right, we're ready to take a movie.
I hope you'll go along with this rather unusual setting and the fact that I remain seated when I get introduced, and the fact that I'm going to come to you mostly through this medium here for the rest of the show. And I should tell you that I'm backed up by quite a staff of people between here and Menlo Park, where Stanford Research is located, some 30 miles south of here. And if every one of us does our job well, it'll all go very interesting, I think. The research program that I'm going to describe to you is quickly characterizable by saying, if in your office you as an intellectual worker were supplied with a computer display backed up by a computer that was alive for you all day and was instantly responsive, instantly responsive to every action you had, how much value could you derive from that? Well, this basically characterizes what we've been pursuing for many years in what we call the Augmented Human Intellect Research Center at Stanford Research Institute. So look what else we can do in here. I've got this file that's structured. If I want to see what's in there, I can walk down the hierarchy levels and see, or return. But there's another thing I can do. There's a root I said I have here. So here, I'm afraid I'll need a different picture of the view. So here's what I drew with a picture drawing capability here. It's a slight map if I start from work, and here's the route I seem to have to go to pick up all the materials. And that's my plan for getting home tonight. But if I want to, I can say, the library, what am I supposed to pick up there? I can just point to that, and oh, I see, overdue books and all. Well, there was a statement there with that name on it. Go back. What am I supposed to pick up at the drugstore? I see, very interesting. All right. Mark it? Oh, I've already seen that. Produce, no, like that. Gee, that's too much. Anyway, so we have this feature of structuring our material hierarchically, being able to move around it very well. When we get a hierarchy, such as I can show you here now, I can do things if I want to just say, I'd like to interchange produce and canned materials. Bingo. And they're all numbered rightly if I care to look. Interchanging them very quickly. Cans are going to get interchanged with produce. They do it and all gets renumbered. So I have ways of studying over, making different views, moving around, going to specified points, and modifying the structure. At the same time, I've seen that I have a repertoire of different entities, like character, knock off that character, replace a character, make that P. So I have entities of all sorts that I can say I want to do operations on, and this basic structure that I can move over and study and get about very quickly. So that is the essence now. That's the essence of the tool we have. There are a lot of details that I've left out for you. And now I'd like to stop a minute and just make sure you understand we're shifting from illustrative material to the real working stuff, in case you wouldn't recognize it otherwise. We've used this tool to do our daily work, and our system has been built, this time-sharing system, for about 6 months now. It's been working. And in that time, we've gone from getting 1 console to getting about 6 working now, with 6 more due the rest of the spring. This is our fourth computer in which we've had this kind of a system, so we've learned a lot about the user features we want and how to be fairly skillful. But this next step about learning how, when you're faced with having this in your office all day, as I now do, in a very exciting sense, how do you put that to work for yourself? How do you organize your files? What kind of things do you do? So to get going on this, let's switch away from the tool we have here and talk about some of the general features of the program, some of the ways it's built, and get back a little later to the nature of our usage of it. So that program involves about 17 people together with the special laboratory facilities we have. It's sponsored by government agencies exclusively, ARPA, NASA, and RADC now, and in the past, AFOSR and ESD, and these were the people that first grub staked us many years ago. All right, and it's been a goal-oriented pursuit for many years, and I think we can just go off and get a quick little picture I sketched to show this is the staffing over the years from 1950 on, and it's had slightly bumpy history. During these years, there was only one of us. But I go back to where I was and say, let's continue on in this file. That link took me out to a different file, to a statement for that view, and I jump back to this file where I was, and now within this file I make a link to another to say, the HIRC is pursuing these goals. Basic goal, improve the effectiveness with which individuals and organizations work at intellectual tasks. What does their effectiveness involve then? Better solutions, faster solutions, solutions to more complex problems, with better use of human capabilities. Really thinking about that. But a corollary goal is, besides improving the effectiveness, to develop a system-oriented discipline for designing the means by which greater effectiveness is achieved. That's very important to us. The approach for this should result in the system-oriented discipline. Let me just show you how I constructed this file. You notice underneath there with that and that, there was just a link hidden here that went back to this view with a slightly different view parameters. To give you that view. All right, there's another one hidden there that says the general approach for us, empirical. We're pursuing this monstrous goal, monstrously difficult, by building and trying empirically. And we're approaching it evolutionary-wise because we feel that it's a whole system problem. You need to get a person in that environment working and looking at the many aspects of his working system that are involved in his effectiveness. That's many more things than just these computer-aided tools. In a large system like that, we need to do it evolutionary-wise because we can't be analytic enough about it at any one point to decide what best our next thing should be. We can only decide from here, as well as we can analyze it, where we can invest our next resources to get the most return at an increase of the effectiveness of the system we have. And this item down here is the term bootstrapping applied in a slightly new sense. We're applying that to our approach, where we're saying we need a research subject group to give them these tools, put them to work with them, study them, and improve them. We'll do that by making ourselves be the subject group and studying ourselves and making the tools so that they improve our ability to develop and study these kinds of systems and to produce, in the end, this kind of system discipline. So it's a struggle doing it that way, but it's beginning to pay off. And I've given you an overall picture about the program, and that's out of the way, and I can just move my marker down and say, let's save that version. So this tool, in pursuing those goals, one of our principal tools is this computer aid system. Let's talk about it as a system. There's a link sequence to jump in there too, where we talk about NLS, meaning online system, a very general term. It's going to be NLS for many, many years, an online system that will evolve. Right now, we consider it to be primarily an instrument and a vehicle for helping humans to operate within the domain of complex information structures. Well, What do we mean by operate? Well, compose, study, modify is the place we started now. We know there are many other analytic things you could do, but we want to get around, study, and modify. And then to further information about what does complex structure mean. We're talking about complex structure and emphasizing structure because we say, although the content represents your concepts, there's a structural relationship between that content entities that should represent the relationship between the concepts of human thought. All right, we never can do that very well with linear text. So inside the computer we can represent that quite well. In fact, we can represent information structures in a computer that would generally be far too complex for you to study directly. But NLS serves as a tool to roam over that, navigate through a complex structure, be able to find your way in navigating, move about it rapidly, and be able to see what you want to see at any given point. That's how we think of NLS as a tool. All right, these are all very important concepts to us because these, together with the bootstrapping, have told us where to start. We start by building an instrument that we can sit at and work during our day to organize the kind of working information we need as a task force developing systems. We need to write our specifications, our plans, our programs, our users' guides, our documentation, our reports, and even our proposals. This device over here is unique to us, and we always have to justify and explain it. We'll do it in reverse order. We'll explain it first. It provides for you the one-hand equivalent of what you can do with a keyboard. There are 5 keys, and normally each finger sits on a key, and depressing any one key at a time produces a character. And any 2 keys at a time also. And in fact, any combination of depressing, of which there are 31 combinations, it'll offer you a character. If I hit W, it'll say delete word. The arrow moves back and forth to give me feedback. My tracking spot changes. That gives me feedback. Now it tells me, since it's an arrow, that it's armed, I can do something. We get a lot of feedback. Let me restore a view like this to show you. This is more normally the way we work with feedback up here. Where here I'm shown, it's not working. That's an echo register that normally gives you the last 6 characters that you use. Oops, not working. All right. The last 6 characters and left shifts continuously, so you can look up at any time and see what have I just struck. And that's very good feedback. Here are characters that show me the different viewing parameters, view specs. They get large at times at which I can hit single strokes that change those view parameters. And each of those means something to me, and their being large at particular times tells me I can hit very quick abbreviation for changing the view. So I can say, all right, I'd like to go to produce, but I'd like to go to produce, they get big, I'd like to say 1 branch only, and let me look just that low, and I see it. Oh, I can say, I'd like to see 1 line only. I can see it. So these ways I move around, the way I get feedback up here, the way I use both hands to coordinate to tell the computer what command and what short literals I want, are all carefully designed to go together to make the repertoire. We've talked about the devices and now the nature of the dialogue, or the kind of feedback we get from the computer for each of the discrete character strokes and actions that the user goes through when he's executing a command. So that system is really represented to a user by the repertoire of commands he has, by the function of each of those commands, and by the control dialogue he has for each of them. So they all together go in and making a design, and to do it well, you have to be very careful about the nature of the functions in that repertoire and the natures of the way they're controlled. So we've developed a very special language for talking with extreme precision about these control, both the command functions and the control dialogue for them. And a little bit later, when we tell you about the programming, Jeff Rulison will bring in some special examples to you of the languages we've used actually to program at high level these functions and the control feedback that we get in these control dialogue. I'd like to link to Bill, and I don't know what his terminal is right now, so I have to ask for somebody to connect me to him audibly. So Bill, will you come in through this intercom?
Hello, Doug.
Hi. I need to know what terminal you're on, Bill.
13.
Okay. I'd like to have him see my text. And so this special thing, if I label 13, will switch over, so in his display he sees my text, so I'll execute it. And sure enough it does. But what's that running around? Well, if he's looking at my text, he'd like to have something to say about it. So we put on a marker, a tracking spot that he controls. So he's sitting in Menlo Park looking at this text, and he can point to it. But we've carefully reserved for me the right to control and operate on this, so my bug is more powerful than yours. But we can have an argument. Yeah. That's what they call a bug fight. So, all right. So in case you haven't been listening, Bill, we've been going through lots of examples and setting up in collaboration here so that we can go on into information retrieval. And we've set up now audio coupling, and then we're both looking at the same display, and that'd be very handy to work. We can talk to each other and point, and maybe later I can hand you the chalk on this blackboard, like saying, here, you control it. But let's stay this mode now and add another feature that hardware-wise is available through the kind of display we have. I'd like to see you while I'm working on it. So before I can do that, I have to set up my display in a certain way. Set it up so I see it over like that. That leaves a corner up there, and I say, now computer, do the automatic switching that'll bring in a camera picture from the camera mounted on his console, such as the camera mounted on mine is. Hi, Bill. That's great. Now we're connected audio. You can see my work, you can point at it, and I can see your face, and we can talk. So let's do some collaborating. You're silent. Oh.
What do you want me to say?
Yeah. There's nobody here but a large audience, Bill.
All right.
All right. So let's go talk about information retrieval. And there are a lot of things I've been showing them and jumping around and finding your way, relating back to the portrayal I gave about NLS as an instrument on complex data structures. It shows them how we can get around and find things. I showed them the content analyzers to help locate things locally. You had a file kind of classifying retrieval stuff. Why don't we switch to it?
By the use of a hierarchy here, I mean working down through the hierarchical structure of the file, making use of the categorization that's built into the file. This we've seen several times. Let's, just as another example to really make this clear, we've talked about the desire to get hard copy of a file, wanting to get something printed out. There's quite a large system that takes care of giving of making a file for hard copy. You're able to specify how you want the hard copy to look by giving various directives. One of the things you might want would be Roman numeral page numbers. So let's go off to a directive file and see what the directive is to get Roman numeral page numbers. I'm into the file now. Here's the first level of the hierarchy. Let's open up page formatting. We want page numbering, so we'll open that up. We find, yes, here it is, Roman numerals. We find out the directive. Yep, your bug's right on it already, Doug. Here's the directive we want. So we've worked down quite a way into a hierarchy, as you can see. This is quite a nice way to be able to very quickly find what you're after.
Okay, that's the end. Not a very good. Thank you. Well, you can't imagine the relief when it worked. So it went on for 90 minutes, and then we thought, boy, the world's going to come talking about everybody's starting to augment now. Well, it didn't happen, but we went ahead anyway. So I just want to show you a few of the things we did physically to the system after that, and then go into some of the conceptual framework. That by 1973, we, well, see, 69 to 70, we were shifting from the 940 to a PDP-10, and that was pretty distracting. And we came up in probably 70 or 71 with Windows and quite a few new features on the system. By 73, we revamped the file structure explicitly like this, so that all of the hierarchical structure is by actually programmatic list structure, and pointing off to the text patterns that were kept in a different hunk of the file, so they're kept separately, and it's only a matter of rearranging pointers to do any of the structure manipulation. And then a capability that, along with any of these nodes and the text you thought of them, which we call statements, that you could have a whole property structure of arbitrary form underneath with different kind of identifiers on them to say, you know, this is graphic, or this is a image scan, or this is a digitized voice, or this is just raw binary data. Because we assume the whole orientation was that our files were document-oriented, and document in a very general sense, that this is what contains an argument, a proposition, a proposal, or whatever, the thing you're trying to map your thoughts and arguments into that form in order to communicate with. So the generalized document. So we, at that time, working on the networks and everything, the best we could do, because we'd shifted off from that glorious fast kind of local display that we had there. That again was for strategic reasons, which penalized us here with the graphics. But we used a Tektronix storage tube scope that would be plugged into the printer port of our display. And there's the guy who had recently come and was working on that for us, named Bob Belleville, who later went to Xerox and helped him with the Star hardware, and then went down and was the project manager, I guess, for the Macintosh. And so the pictures of the graphics that we could pick up plotter files from anybody else's graphic system and ingest, or having our own rough kind of portrayal capabilities for a graphic subsystem, and we could see them on the Tektronix storage scoop like this. Or if we went through with our photo typesetter kinds of directives, we could say that it should be scaled and installed in the page of a formatted document of this sort. So all this was available by, say, 75, 76, but the problem at the time was that for someone to use this, they would have to buy this $10,000 or $15,000 terminal and, you know, the storage tube to go with this. And we couldn't get past this business of, if they don't have it, they don't know they need it, and if they don't know they need it, they don't want to buy it. And it was a little difficult at the time. So the graphics sort of atrophied until recently. Then another thing we did, though, and this was 1967, a lot of what we wanted to do there was help people collaborate. So one of the things we did was, here again, Bill English whipped all this together very fast. You know, special small narrow tables that you could work around, sit in a conference meeting with our monitors sitting in here down low enough so you could see over them and see each other well. And then they all had the same image that was brought from this was our one user 3100 at the time, but we had one workstation here and mice there. And then anybody who wanted to pick up a mouse and push the button, then there would be a large cursor that they'd be controlling to move around there, so any one person can point to the common display thing like that. So we held a review meeting among our sponsors and the like at the time there, and there's Bill English and Don Andrews and Dave Hopper, and this is Barry Wessler, who was Bob Taylor's assistant, and Bob was in here someplace at the time too, participating in this. And another thing we did by 1970 is bring up our mail system that was part of our collaboration too. And it was really a very sophisticated mail system with user ident catalogs and all sorts of fields that you could use to send and answer things. And one extra feature was that the things, you could send whole documents. It didn't matter whether it was a little one-sentence thing or a whole document, it'd be around. So what we did was have it so that a document could go in and be cataloged into a system we call the journal. And that's like actually pasting it down on the table because it was going to be there. And then with the fact that we had our linkages and internal addressability like that, another document could come on here and just point to that. So the successive documents that were entered in this system could easily be cross-referencing back to each other, and it kept what we call our recorded dialogue. And it was just an important part of how we assumed you needed for a community of people to work together. So that's an extremely powerful sort of thing. We just recorded by about 75. I was just experimenting then that every one of those things was printed out up here, and so they're stored by number in a printout like that, and that's how big it got in about 4 or 5 years. And the number now for that particular journal is well over 100,000 items, and now we have arbitrary other journal systems that customer groups can install administratively for themselves, and it's a very powerful sort of potential. But I want to just shift now back to that conceptual structure, conceptual framework. And in that 1962 paper, it was very sort of saying, I had this immensely intuitive feeling that humans are going to be able to derive a great deal of capability from this. And along with that had come very real images in my mind as sitting at a display console, interacting with a computer, seeing all sorts of strange symbology coming up that we could invent and develop to facilitate our thinking, since we would no longer be limited to working with paper and laborious means like that. And other people could be sitting at similar consoles tied to the machine, and you could be collaborating in brand new, exciting ways, and that you could be just doing all sorts of things to control a computer. So I had enough engineering background, even though I didn't at that time know how the innards of a computer worked, but I certainly knew that if they can read a card, they can sense keys and any other action you want to do, and if they can drive a printer or a card punch, I knew plenty of electronics to know that they could put whatever you want on a display. So what I didn't understand at the time was the economics and all of that, but I said, look, I got a whole career ahead of me, let's go after all this. So, but by 1959 or so, I got a chance to sit down and say, how would that really work? So I'd end up, as an engineer would, as sort of stripping it down to some of the basics and say, I can't get much more basic than this. There's a human wanting to do his knowledge work. He's got this kind of capabilities within his skin that we can make use of. A lot of mental capabilities we know of, and some of it he's even conscious of. And then you've got marvelous machines there, motor machinery to actuate things in the outside world, and sensor and perceptual machinery to get an idea what's going on. And that's what he has in order to act in the outside world. So that's what you start with, and how can we improve his capability? Well, it turns out that there's been a lot of people working on that for many generations. And we've got a whole culture of things that you get up and you're indoctrinated and trained into. And you got lots of concepts and indoctrination down here, so conscious things and unconscious things, lots of skills motor-wise and perceptual-wise that we're not even aware of. Like, just how long do you think it took to learn to brush your teeth? Takes quite a while. That's a skill. Okay, those things mostly are developed in order so they can interact with this layer of other things that our culture provides us. Okay, there are a lot of things in there that are brought to you, tools and all sorts of stuff that let you live within a social structure and be effective at your interacting. And there's a whole subset of those that help you be effective at your working with knowledge work, etc. too. So take all those things together and call them an augmentation system. That's what augments humans. And for good practical purposes, let's make two parts of that. One side's got all the technology in it, and the other side has all the other stuff. So I call them tool system and human system. All right, training, knowledge and skills that you got to install. Language, an extremely important invention. It just transcends as an invention anything yet we've come up with here. The methods and all that we use to knit together all the little steps that we can take ourselves during the day are extremely important. Our customs for working, our procedures, the way our organizations are done. They're all done so that humans can do something. So you look and say, within that sort of picture, framework, any given capability that a human has is really composite. It's made up of making use of a lot of these things, and a lot of these things with kind of skills and here in training and conditioning and all the customs and the things you just accept and all the mental skills and the language that you've learned in here. So that's the kind of thing you say, we've got to work on boosting people's capability. So along comes a lot of new technology here, and that's great. But the technology side alone isn't what's going to really make all the difference. So let's just go on a little bit more with the kind of picture. These were all in words in 1962, so this is a since then kind of way to graphically talk about it. So look, our real capabilities are sort of essentially hierarchical. You know, we learn a lot of lower order capabilities like writing and typing and reading, etc., like that. And then you got higher capabilities you build on top of those, and on up until you really, that's you as an individual, a bag of capabilities. Or that's an organization and the capabilities it has at many levels. So if we bring in something in here, you know, a longer lasting pen, it's going to make a little bit of an effect. But you bring in the kind of technology that even in 60, it was just clear to me the kind of things are going to happen. Incidentally, because I'd had this strange obsession, and I realized by the late 50s that it sounded very weird. It doesn't take much cleverness to realize that in the face of the kind of reaction I was getting. But so I got the chance before I could work on this to do some semi-theoretical work about what was the potential for digital componentry as far as the scaling in its size and speed went. And I really learned a lot and opened up that and did dimensional analysis of it and began to realize that we scale things down, and the limit of how small and how fast the things can get is very, very small and very, very fast. And that don't worry, with the kind of pressure that was apparently going to be there economically and all for driving digital stuff, it was going to have these kind of curves like they've been talking about. So great. And it's going to take a long time to learn how to make all these changes over in this side of the world. So start gearing up and experimentally get the best things you can moving here and start learning about the changes in here, because that's going to be the really long time constant to make the change. So let's go. So that was the framework in 62 when I was starting to say, hey, I want to do things. And one of the things to look at in here and realize that most of what you hear about today and all of that is heavily, heavily emphasized in here. There's a strong intuitive feeling that that's going to make a difference. And you can even see in today's ways of doing things, yes, they can come in and make immediate changes. So this side of this two-part system has really been driving it. So what just this morning, someone, I got this great thing. These are semi-augment people. You know, semiconductor people. So anyway, that's only part of the story. And what you have to do is the co-evolution between these things. And so how do you make an environment that gets the co-evolution? Well, that's where all the bootstrapping in the laboratory I said I wanted to do, et cetera, was going to be like. So come over here and start becoming more conscious of the candidates for change in this side. And so that's where I said, look, you know, well, I could show you more examples like that. But anyway, that's the thing constantly. So whenever you hear somebody say, it's got to be easy to learn and natural to use, put up a little flag and go question it. Because what's natural, see, is the natural way to guide a vehicle is with reins. Well, that lasted a long time. No, what's natural is some way balance that you can grow up in a culture and learn. And if you look at how much it took to learn to drive automobiles and own and operate them like that, it just make ridiculous the things people talk on now, what they expect your computer systems learning to cost you. See, if it's going to be the kind of working companion that it's bound to be, that the learning part of it is relatively trivial, and I know it's what sells now because the market isn't very mature for people to buy things that look like they're going to be hard to learn. But I'm talking about the long-term trends and the responsibility of the people that are in there doing the research and downstream planning. I think they really have to start looking for what kind of high performance can you get from these things, and what are the candidates in here to change so that you can harness more effectively what you can do over there. And that will bring up lots of things in here that might not have been even thought of before, because now you're looking for ways to do it differently. So the mouse and the key set, trying to do something new, the structured files and documents and things like that. We're starting things in here to get them going. And I didn't realize how strange they'd seem and how long it would take for people to start considering them at the time. So then how does the change take place? Say in a large organization that this might go like that. You realize that There are lots of different parties taking place in a change. See, an idea for change here has to ask for it up here. That's needing something that changes down here. That makes a change here. That provides something new here. And it's a reverberation up and down. So when you've got a fairly large organization or a large system of things, and you've got specialists working all over the place that are responsible for the changes in certain things, you've got to do some extraordinary sort of communicating. And the kind of evolution our society has been providing us with over the centuries before that, those changes took place so slowly that we weren't really aware of the evolutionary process. People moved and finally heard about something and trying it. But with the catapulting rate of change here and the pressures to become more effective, the changes in this whole thing within our organizations are just going to exceed the rate that we know how to do it in. So many structures in here, that changing rate's going to exceed the elastic limit and things are going to break unless people start getting conscious and understanding about the evolution. So I said, Jesus, what better place could you start putting to work the new tools and things you can get here than in the processes that are going to facilitate the evolution you have to go through? And that was a strong push towards the documents, towards collaboration among groups, etc. Sorry, one way you could look at, say, how could you use the computer to help you work with your documents would be this, a very straightforward way. The person sitting there running this thing, computer storage, I could display it to myself to make it look like a page, or I could put the pages out there. What you see is what you get. Great. See, and it's a totally flat image about thinking what's going to change. So it didn't even enter my mind to do that. Problem, I guess. Here's what I thought instead. Hey, look, I says, you want open-ended command vocabulary, because once you get hooked up to running this environment like this, the computer tools you got here like that, boy, you're going to have more and more functionality. Since you got a very powerful beast that can do things, let's really look for fast control so I don't have to do things sequentially in my hand and concurrently and such like that. Let's make it so that I'm storing both content and structure in here and I can manipulate it. Bring text and graphics in there because they're both important. I want every object in my file to have a name and an address. I can address at least, and I can arbitrarily label or name it if I wish to, because I want to do remote jumping and manipulation on that. And I want to be moving around in that very fast, so my position in a file, I want it to be able to be exact so I can go there very quickly with all sorts of ways the computer can help me navigate and get to different places. And when I get to a place, I want to generate a view that at the time is the best thing to serve my purpose. So, Windows cutting it up like that, just looking at things with levels, how many clips, you saw a few examples there. So I said, it's that kind of basic thing. And so finally what I'm displaying to myself is what I asked for the control here to go through that structure with the sort of conceptual orientation, the addressing, the labeling, and the structure that I've done myself to represent what I'm thinking about, and I can get there. And so when I'm moving around too in somebody else's stuff, that I can study and analyze it much more effectively. So then I put on a display that I can train myself maybe better and better, because a display may not look as you expect it to look when you're looking straight down on paper, and indeed it doesn't. And I want it also so that I can share that display with others, so that I can collaborate. See? And shared files over here are another part. So that's the image, and that's why the NLS that was in that show was built like that, for some of the reasons. Okay, architecturally, if you're going to have a whole bunch of tools, way back early we say, look, you're building an application program on top of an operating system in a computer working for the terminal. You've got these two facets of it, the interface thing and the actual thing that does the substantive work, two different parts. Let's think about them and pull them apart. I don't want the smart-ass programmer here who knows all about how to run this to think that he's the one then that should tell the world how to interface with that. So there's a little bit of argument. There were lots of that kind of programmers around, you see. It's a little bit of argument, and we say you have to wear a different hat here. So by 1968, we actually had our evolving the programming language different for this from this, to specialize for what this had to do. Then you come up with a thing of saying, why for each different application package in there should you have a different front end? No, that's sort of a universal thing. So this is where our heads were by the end of the 60s, like that. So this is actually the picture that was in the fall joint the proceedings at that time like that, showing that all the subroutines that did our work went with our special language we had to develop on the 940 to program and compile the functionality. But forget the control processes, that was specified in a control meta language that had a control meta language translator that said that what to do. How did we make that? Well, we had a tree meta translator that let us do our compiling. So we described a new compiler in here and compiled it there. We had our tree meta compiler, our control meta language compiler. And so we followed this soon, and all this has evolved very much to very flexible kinds of things. Incidentally, in those days, I talked about control language and control meta language rather than the command, because I just felt you're doing a lot of things that normally people don't think of as commands, but the pressure is pulled around, so now we call it command language, etc. So then it was really fortunate for us to be involved with the network. That was really great. And the idea then of a community, and one of the papers I wrote was saying, hey, that turns it in. It's a lot of functionality that you're going to have, and you can share data, et cetera, but what it really can also provide is a knowledge marketplace that's wide open for people sitting at the terminals all over the place like that. They'll just be brand new, and that's the way the concept goes. So topologically, this is what we assume for years you're going to have. And we wanted to go ahead and say, let's don't argue about how much functionality is any of these places. These are workstations, and who cares whether they're smart or not, as long as they do what they want to. Where could the functionality might be out here or out here? You know, what is the performance and the economics and all of that? So let's look at topology. So the topology we wanted to do is say a user interface system that's between the guy's hardware interface stuff and all the smarts. And I don't care how much of this is in his workstation, but I'm never going to say it all has to be in his workstation. And having a bus here that's essentially out through all the networks is extremely important. And a big important part of what you want to provide him is a set of functions that he thinks of as his private workplace. And he does all this editing, mail, document, calculate, and everything like that. But also he can reach through this to get at all these other functions. So, great. We have an architecture like that with a virtual terminal controller, so everybody out here talks about a virtual terminal that translates. The hardware here can evolve very much. Terminal characteristics can change like that. A command language translator that flipped in a new grammar gives them a new language. User profiles, so the recognition mode and everything else can be variable by the user. And very important that out through this bus, we generalize and have a call return sort of remote procedure call. So in the mid-70s, we were developing this, and that's the way it runs now, a remote procedure call protocol, so that out through that network it works. And this thing can reach out with that remote procedure call to one kind of applications, a translator to drive things that can only run by terminals or go through transparently. Profiles of functionality different users want to get from all those packages out there will depend upon the user. So great. And his concept and command language, great. So this lets the evolution of the user side go on maximally. Basic human unit like this, how are we going to evolve that? The reverberation of the evolution is a very important concept in there. So you say, that's only done by what you'd call communities through there. And this is a big important concept that started in the mid-70s. We need a community that's going to interact. We need to build support systems for it. We need a conscious evolutionary activity here to build that for the community. The concepts were, look, start doing the things for that community that facilitate its doing it, that facilitate being improving it, the bootstrap. See? Okay, that's what we kind of hope to do with the ARPA network people. We would really support that as a committee. So when they announced the ARPANET, was sitting there, oh boy, it was the spring of 1967. Bob Taylor and Larry in a ARPA sponsors, or principal investigators meeting told us we were going to get connected, and they were right. People didn't like the idea. I was so thrilled. Finally, I said, I heard the interactions go. I says, hey, I'll build a network information center. And what I wanted to do was build a community support center that would really go after this thing like that. And if there's a sub-community among there that in itself was interested in augmenting, boy, look at the kind of leverage you get like that. So I've talked about a bootstrap community in my notes for 15 years now or more like that, and that's really what can go. And there are activities that are there that we shaped a lot of the work in NLS to be able to facilitate. Unfortunately, the ARPANET grew so fast, as Larry said, that the Network Information Center had trimmed down what it could do functionality till it was a pretty, it couldn't do all that. And this is the kind of a picture about what communities can do with what you could do to support a community by integrating a lot of its dialogue and get intelligence system there, handbooks that kind of evolve to integrate what they want to do, facilitation staff. And here, there's a lot embedded in this that what Augment is built, or NLS Augment is built to be able to do with the sort of external document control, the community's intelligence collection that they all contribute to and participate in, indexes to that, and an equivalent of a handbook being built in there. And so this is the kind of a picture. I'm going to terminate with this. Actually, now that I've been, since about 1976, we really had no chance to go with this. It didn't fit in the pattern of the research at ARPA, at what SRI wanted to do. When we got out in the commercial world, we found that wasn't what people wanted to do. The Augment thing stayed alive in sort of a funny, dumb way of taking this bulldozer in and helping people in their backyards do work. McDonnell Douglas bought Timeshare, and inside of that organization, it's a very different thing, very heavy knowledge work organizations. And for a year, I've been going out through all those people involved in CAD systems, a big project, and finding out that these concepts are what they're ready for now. So we're starting this year to build special interest communities out through there. The first one's the AI community, a community. These are all these distributed people. We're going to be able to give these services and start bootstrapping. That's exciting. So that's my historical.
Are there a few questions for Doug before we break up? In the front.
Hank Straub, AT&T Bell Laboratories. Wondering, I'd like to hear your feelings on why it took so long for the mouse to be adopted into personal workstation technology and why that hasn't happened yet with the core key set.
Let's see. To be pedantic, do you want my feelings or an explanation? No, that's all right. I don't know. There's a, it's part of a larger story that I think fits in with culture. That if you look at the whole map I drew there and said all this human system side, all the opportunities to change there, and how the technology side has just grown way out of proportion, in my view, just stupendously so. And fifth generation and all the hoopla about that is just all the more push in there. So there's got to be balance. Well, there's a reason that in our culture we grew up and absorbed all of the human system side that we use without even questioning or thinking of it. They didn't come to us as inventions. And if we look back upon other cultures who don't have the idea of progress and laugh at them, all we have to do is turn and look at that and realize our culture yet hasn't gotten the perception that that part of it is open for progress and change. We more or less resist the change and say, boy, I'll be damned if I'm going to let that computer make me change. And if it's so smart, it ought to do it for me. And it's totally missing the point in my estimation, see. Well, people look at the mouse and say, geez, who wants to do all that? Or the key set's even worse. But that's all I can think of as part of the culture. And the biggest challenge that's ahead for us, if we want to make progress in this, is to start affecting the perceptions that people have about what the potential is there and looking for change and finding out a rational way to do the evolution so it doesn't break us apart. And I just love to get in the dialogue with people then about the strategies for that evolution. So I found people in McDonnell Douglas who are talking about it. It's a very progressive corporation. I'm really surprised. Up at the top, there are guys who they say, we're going to remake the corporation renewal. They'd started that. Ethical thing, participative management, great things. That's given people at many of the other levels the courage to just go ahead and buy. I come up and say, strategically, we ought to do this. So they're sticking their necks out and getting me a chance to start. But it took something like that. Geez, that's a long answer. I could give you another half hour.
Doug, I'd like to ask you, have you considered combining the mouse and the key set into a single device, a handwriting recognition system? Thank you.
Yeah. I thought I'd have a mouse and a key set in each hand. Sure. There's a lot of potential there. And people say, hey, what about this number of buttons on a key set, or mouse? And I says, well, why'd you pick 3? Well, that's all we could get in at the time. So yes, I go for more. And there's a lot to learn. I've pictured that. I even did a lot of thinking one time about the ways that you could get transducers to pick up almost any kind of a signal that your motor system or afferent nervous system could produce, and translate that into actions you want, and it's a whole new control language you could learn. And just wondering about the bandwidth and the effect of that, I could just picture really going through space. It's wide open.
My suggestion was not to increase the number of transducers, but to decrease them to a single one, to handwriting recognition, so that you don't have extra buttons. You only use one hand to do it.
Well, that's a pretty slow way to enter characters for at least English. And so, try it. But I think that if you've got such a marvelous machine there, you don't want to keep driving it with reins. And that's what I think the handwriting recognition. And I feel similarly about speech recognition, that it's very nice in a lot of ways, but you couldn't control a system like we're doing it there. Just that's the way we work. You couldn't do that with speech commands. You couldn't go fast enough unless you got some very sophisticated signals that you had to learn how to do. See? Is that an advantage?
Any other questions? I have 2. One's on the tool system side and one's on the human system side. Let's take the human system side first. Given the work that you've done in this area, what insights do you have about the changes that are going to be required in the human system, given the changes in technology and in the tool side that we are experiencing today?
It's hey, what happened to my mouse? Oh. It's just very important to have a wife. Well, I've got a lot of general ideas, and I can tell you some of those. And the main need is to find the evolutionary process that starts exploring that. Many people and many things to try. Examples are that our organizations can get much flatter. The kind of communication can be so much greater that if I could just go like this and be in voice contact with you, same screens, diving around the information we're familiar with. You can be any place in the country. It can consider kind of roles that we can have, lots of specialty roles that can flip in and out of your work to help you from any place in the country, that there isn't any way it would have been practical with the kind of time constant it would take before for you to get together and go look at your stuff and get back and separate. And administrative and managerial structures can be different. And things like the matrix organizations, which have a lot of appeal in project-oriented environments but are difficult to administer, have a whole new breath of life coming to them because of the kind of coordination and communication. And working groups that can be separated geographically, who cares? I mean, we do it a lot of ways now, but no one's been really focusing on the pursuit of the ways to collaborate. Lots.
On the tool side, a lot of the technology that was developed at SRI and later has readily transferred into other commercial products. Yet there's some, like the high points probably being the structured text and the view controls that you had over the structured text, the linking mechanism from one place in a document to another place and possibly another document, and the notion of a mail system that is supported by a database, an ever-changing database of all of the mail that has been sent and that's automatically indexed. Those things haven't readily transferred into other products. Why is that?
I was hoping the historians would answer that. As, I don't know. It's puzzled me, and I used to take it personally, and every once in a while I have flashes of that. But I really, all I can say is that it just didn't fit cultural perceptions. And when the computers first started becoming really available through the personal computers or time sharing early like that, it's enough for people to sort of make the adjustment to start interacting with it. And if the marketplace isn't ready for something like that, it's who's going to invest money in trying to get it out there? Well, who has to decide to invest the money? It's guys who've been in the business for a while, and they have to depend upon consultants they're experienced and familiar with, which aren't very often the ones that are in the vanguard front like that. So that whole process of who gets it out there and decides they're going to invest the money in it and risks it or goes out and tries to train the customers. And also once you get a system built that you figure is your best bet to hit them, then you've got to put a lot of money into PR that tells everybody that's the best, see? And so you're doing yourself in down the street if later on you come back and say, well, now this is the best. So anyway, a big part of the user organizations have to get in gear and start saying, quit coddling us, you know, we're ready to change. We're looking for what to do better, you know. Don't give us this blah, blah, polite language for what I really think about easy to learn that's good for me, see. I mean, I got a thing about all that.
One more question.
Yeah, I noticed in reading one of your early reports, my name is Larry Press, by the way, that you'd get paid a lot of respect, I guess, and comment a lot on Vannevar Bush's suggestions. And I just wondered if you could comment on how important you feel he was to his thinking and also his work to the development of all this interactive computing.
I don't know about other people in that respect. For me, it was part of a singular thing because I was a little Navy boy, electronic technician in World War II out in the Philippines, and getting moved from one place to another, and they stick you on an island to wait to assign you to somebody else. And somebody said there was a library there, and it was a Red Cross library, you know, up on stilts in a native hut. Really neat. Nobody there. Go in. I was poking around. I found this article in Life magazine about his Mimex, and it just thrilled the hell out of me. That, you know, that people were thinking about something like that. So I didn't really act on that, but I'm sure, you know, later as I got into this that it started to affect me. And then later when we were starting, the parts of the way NLS is built, there's a thing called a sequence generator that you can flip in your own user choices of a sequence that goes and picks you this thing. That and the links were all a lot coming from his idea of trail generation through his documents and that. So it was a very explicit connection in that respect. I wish I could have met him, but by the time I got onto that, he was already in a nursing home and wasn't available. History is moving faster nowadays, incidentally, so you can find some of us old fossils that are still alive.
Thank you, Doug, very much.